Good morning to all of you. I welcomes to all in our lecture series on mechanics, that is your core paper 2. The topic is special theory of relativity. In our today lecture we are going to be discuss about Galilean or Newtonian transformation and Galilean relativity or Newtonian relativity. So in our last class we have been discussed what is called as the Newtonian relativity and what is the difference between Newtonian relativity and Einstein relativity in detail. So here, before we have to discuss that a particle is going to move with a speed of the light and how its physical behavior is going to be changed, and it is not to match with Newtonian relativity. Here, it is need to discuss about Galilean or Newtonian transformation and Galilean or Newtonian relativity. So let's start. So in figure 1a, this is 1a. In figure 1a, you can see that two frame of references are coincided at O, or we can say O dash also. That means two frame of references. Here you can see this is your x axis, this is your z axis, positive z axis, this is your positive y axis. Two frame of references, that is S and S dash. Both are coincided at t is equal to 0. So the x-axis, y-axis and z-axis all are coincided at this point. This point we can say O or O dash. Let this situation is at t is equal to 0. And a point P is steady or stationary in your S frame. You just concentrate that S is your green color and S dash is your red color, and the observer both are sitting at O or O dash, we can say at t is equal to 0. Okay, so the coordinate of P for S frame or for this observer who is sitting at O in S frame is x, y, z and t, and the observer, this is red one, which is sitting at O dash in the reference frame S dash is written as in the form of x dash, y dash, z dash and t dash. So at t is equal to 0, t is equal to 0, both x, y, z and here x dash, y dash, z dash will the value will be the same. Okay. Now we have to consider a situation that suppose S dash frame. Here initially at t equal to 0, both S and S dash coincided at this point O, or you can say O dash. So when time lapse, after some times, suppose we can say after time t, this S dash frame moved a distance with a velocity v. That means we are considering that S frame is stationary, S dash frame moving towards positive x-axis direction with a velocity v. So after time t, how much distance it has to be covered? It will be cover v into t. Okay, so this much distance will be v into t. Okay, now what will be the coordinate? Here when t equal to 0, here x equal to x dash, y equal to y dash, z equal to z dash. But here you can easily perceive, or you can easily understand that this x dash will be changed, because the observer which is sitting here in s dash frame, now this x dash s dash frame, the x dash will be how much? From here to here, this is your x. From here to here, this is your x. This is distance is vt. So x minus vt. So x dash will be x minus vt. So when the observer is moving in S dash frame towards positive x-axis, after time t, its coordinate is going to be changed, or the point P coordinate is going to be changed for this observer, but it will be steady, or it will be, we can say that the stationary. This point will be point and its coordinate will be stationary for this observer. So this is the these things happens whatever I drawn this figure. And what I discussed, same thing it has been written, just I am reading, you just watch. Let two inertial frame of references S and S dash having coordinates axes x y z and x dash y dash z dash are coincided at O and O dash. O or O dash. O or O dash. You can say O or O dash at time t equal to 0. This is your figure 1a. Okay. The S frame is stationary. Here we consider that S frame, this one, this green one is stationary, means this person is stationary who is sitting at this origin O. This is stationary, it is not, he is not moving, but as this S dash frame is moving, so this person obviously is going to be moved. So here we consider that S frame is stationary and S dash frame moves to right with the speed v. Okay, relative to S frame along x axis, which is figure 1. Figure 1b represents by figure 1b. The two observers at rest at the origin O of S frame and O dash of S dash frame coincided at same point at t equal 0. That means at t equal 0, both origin O and O dash and the observer who is at O in S frame, who is at S O dash in S dash frame, both are at the same point. Both are at the same point at t is equal to 0. Both are at the same point t equal to 0. Okay. Let a point P which is at rest in S frame. Now we are considered a point P which is at rest in your S frame. S frame, not S dash frame. S frame. This point is stationary or rest. We are accepted. We are considered a point P which is at rest in the S frame. Now, therefore, at t equal to 0, the coordinate of a point P for observer which is at O will be, which is at O or in S frame. You can write S frame or in S frame. No need to write. No need to write. It will create somewhat complexity. So the coordinate of a point P for the observer which is at O. O means obviously it is S frame, will be x, y, z and t. X, y, z and t. And the coordinate of point P for the observer which is at O dash, that means in S dash frame, will be x dash, y dash, z dash and t dash. X dash, y dash, z dash and t dash. Okay. Now at t equal to 0, we can easily observe from this figure 1a that x is equal to x dash, y equal to y dash, z equal to z dash, t equal to t dash. Okay. Here t equal to 0 means t equal to 0, t dash will be equal to 0. So all the coordinates is going to be equal. X equal to x dash, y equal to y dash, z equal to z dash, t equal to t dash. Okay. After time t, here we consider after time t dash. Suppose after time t dash, the S dash frame moved a distance v into t along positive x-axis direction. See, if this S dash frame is moving with the velocity v, then after time t equal to t dash, suppose after time t equal to t dash, what will the distance? This will be v into t, or you can say v into t dash, because here we consider t equal to t dash. Okay, so it will be v into t. This distance will be v into t. So obviously x dash coordinate, or we can say x coordinate in S dash frame will be changed as compared with previous, but y coordinate and z coordinate will be same, whatever at t equal to 0. So after time t equal to t dash, the s dash frame moved a distance vt along positive x-axis direction. Now the coordinate of point P from S frame is x, y, z, t. Here we consider after time t dash. Okay, and the coordinate of a point P from S dash frame will be x dash equal to x minus v vt. So here t dash and t creating somewhat confusion. I am going to change over here. You just see here t you just change for t equal to 0. Here t equal to t dash will be equal to how much? Will be equal to 0. Okay, at t equal to 0. Here after time t, that means in after time t in s frame it is considered as t, and in s dash frame is considered as t dash, but both are will be equal. Both are will be equal means you just imagine the person in green color who is in the s frame, he has a watch. He has a watch. Okay, this person also has a watch. So in a Newtonian mechanics, if this person is spent for 2 minutes, time 2 minutes, obviously this person also spent the same time, that is 2 minutes. So here we consider that t equal to t dash is equal to t. T equal to t dash. Here t is the time observed by the observer in S frame. Here t dash is the time observed by the observer in S dash frame. Both are equal, that is considered as t. You just change here and here. Okay. So now the S dash frame moved a distance will be equal to Vt along positive x-axis direction. The coordinate of point P from S frame will be xyz t. The coordinate of point P from S dash frame will be how much? X dash, y dash, z dash, t dash. What I discussed, y dash will be equal to y, z dash will be equal to z, t dash will be equal to t. But here x dash will be x minus vt. See, this will be the x dash. Now this will be your x dash, right? This will be your x dash. After time t, this will be your x dash. But this distance will be how much? This distance, this is your x. This distance minus this. Okay, will be x dash after time t. So after time t, x dash will be x minus vt, whatever I written over here. Y dash will be not changed, will be y, z dash will be z, and t dash will be t. This is nothing but called as your Galilean transformation. So the so-called inverse transformation will be just, it will be add up, this will be move this side, x equal to x dash plus vt, y equal to y dash, z equal to z dash, t equal to t dash. That means if I am going to be consider x will be x dash plus vt. If this will be the stationary, this will be the stationary, then then this x will be x dash plus vt. So this will be the so-called inverse transformation. I will be suggest that up to this much you have to remember, and this will be required for our further explanations of your invariant of Galilean transformation. And also you have to you can remember this inverse transformation relations for future applications in our preceding sections, whatever we are going to discuss. Okay. So here I will just giving the somewhat information about inverse transformation relation, that here we consider that this frame of reference is steady and this is moving. Now you just think that this is steady and this is moving, means if this observer will be think that no, I am the steady, so that means this observer is moving backside. this observer with respect to this, if this observer will be think that I am moving, that means this is the reference. If this observer will be think that I am the steady, then this is moving with respect to this observer towards this side, towards this side. So initially, the initially x dash, if we are going to consider, this will be the first case, x equal to x dash, y equal to y dash, z equal to z dash. But if this person is going to move this side, then x, this distance will be x dash plus vt. Okay, so x, this x will be x dash plus vt. If we are going to move, we are going to consider this observer is moving towards this side, negative x-axis side, with respect to this one. Okay, so only for that it will be x equal to x dash plus vt. So y is not going to be changed, z not going to be changed, and t is not going to be changed. So thank you so much for watching this video, Galilean transformation and Galilean relativity, and go through this video and write down the note perfectly and ready for the invariant of Galilean transformation. In this topic we are going to be discuss that in case of Galilean transformation, suppose this is a rod, this is a rod in both S and S dash frame, which are coincided at t equal to t0, and after sometimes this S dash frame moves with a velocity towards right, and we can found in both frame, in S frame and S dash frame, the rod length will be invariant, will be same. That we are going to discuss in our next class. Thank you so much for watching this video. Thank you.